and share the screen. Awesome. All right. Thank you everyone for coming. Let's get started. So a few years ago, I was at a conference. I think it was AIDS 2019. And for those who don't know how academic conferences look like, this is how it is. And while we're having a conversation, a waiter approached us. And we were talking about games. It was a games-related conference, and he joined in. And it was really nice to have that conversation. At some point, he said, "Oh, I would never be able to play computer games. There are too many keys." I was like, huh, okay, that's a statement. Several years ago, I think this was 2020, I was back home and I was having a conversation with my mom, and we were drinking some tea and reflecting on my upbringing. And I asked her, "Mom, why didn't you play games with me while I was growing up?" And she responded by saying, "I didn't play games with you because they made me feel incompetent." I was like, huh, sucks for you, Mom. And then went on with my day. So this is 2020. And Tad, who is in the audience, I think, hey, Tad, sent this tweet. He said that Below was his favorite game in 2019. I was like, yes, let me buy Below, play Below so I can talk with Tad. And Tad is a game designer that I really look up to. So it was important to me to play the game, have an opinion on it, and then basically talk with him. I just couldn't play it. I couldn't get into it. I played it only for 48 minutes, and it's a much, much, much bigger game. And so I couldn't share this experience with Tad. In all of these different experiences, there's an underlying sense of helplessness that the game makes us feel. And when I couldn't play Below, when I was rejected from it, sure, I didn't get to engage the game's contents, but more importantly, I couldn't connect to Tad using that. And similarly, a potential connection with my mom was lost because games made her feel incompetent. And the waiter there, or that other people out there, there was a blockage in my connection to them and their connection to other people because they are rejected from these games. So for the next 48 minutes or so, I'm going to be talking about games a lot. But I ask you one thing. I want you to focus on the people and not the games. What you're seeing right now, and let me share sound. Yes, what you're seeing right now is from a fighting tournament called EVO. It's a Street Fighter match. It's an important match. It's in the finals. But I want you to draw your attention to the bottom left. Something incredible is going to happen. So what you saw was an incredible feat of athleticism, even though it might have not looked like it. The point here is that this project is important because if people are rejected from games, they will not be able to join into the cheers and actually participate in the sense. So I ask you to focus on the people and not the game. Thank you for coming to my dissertation defense, Design Out Helplessness, AI Interventions for Game Inclusivity. My name is Batu Aytemiz, and I'm a current PhD student at the Design Reasoning Lab at UC Santa Cruz's Computational Media Department, and my advisor is Adam Smith. All right, so let's get into it. There are more than 3 billion video game players. I assume some of you are today. And this number is growing day after day. Some of you might recognize this character. This is one of the titular characters from the game Among Us. And Among Us became very, very prevalent sometime during July 2020. You might remember that little thing called lockdown. And millions of people and players at the time used Among Us to connect to their friends while locked into their houses. So just imagine not being able to engage with this game, and due to that, not being able to spend the time with your friends when there were no other avenues that were readily available. And even World Health Organization actually recognized this facet, and they started a campaign saying, play apart together, where they sanctioned that games are a ways people connect to one another socially. And multiplayer games are a source of connection, and this is not necessarily a crazy idea. People have been writing about this for decades now. And I would like to push this idea a little bit further and say that video games are a source of connection, regardless of them being multiplayer or not. And the kernel of this idea comes from MJ, his talk called No Single Player Games. And in his talk, what he argues is that very few people actually play games by themselves. There's either someone watching or there's someone that they're talking with. And so when you're rejected from a game for whatever reason you cannot play it, you're not only rejected from the game's contents, but also your friend groups that play that game, or fan groups. The other people are really, really excited about that game and want to create things around it. Or modding groups, people who are building on top of this concept, or interest groups, people who are racing on it, playing at a peak level, athletes. When a game rejects you, not only you're rejected from the game, but also all the social connections that are built around it. And so hopefully I've been able to convince at this point that we use games as a channel to connect to one another. Exclusion from games cuts off this channel of human connection. And so we need to ensure games are inclusive, not for the sake of games, but for the sake of people who play them. I keep throwing around this word inclusive, so let's be a little bit more precise when it comes to that. I'm using the term, I'm grabbing the term from inclusive design. So what is inclusive design? Inclusive design is developing a diversity of ways for everyone to participate in an experience with a sense of belonging. So I just want people to feel a sense of belonging whenever or whoever they are, whenever they're playing games. So this is our context, right? Like this is the problem that we're trying to solve. So what do we do about this? To improve game inclusivity, we should minimize failures and make video games easy, simple. I mean, we all use ATM machines, right? Like minimizing failures in an interface is objectively good. You really don't want your users to fail while using an ATM machine. Unfortunately, that ideology doesn't really transfer into games very much. So let me explain why. I used to think this way, by the way. In my first 2 years of my PhD, I was like, yeah, minimize failures and everything will be fine. It wasn't. A lot has been written on this topic. The Art of Failure, Jesper Juhl, is a whole book that really engages with this idea of failure. And in an earlier chapters, he actually looks at it from an empirical perspective. So in the top axis, you can see, on the y-axis, you can see the rating that is given to the game. I think roughly 80 players played this game. And on the bottom axis, it compares people who have lost some lives, which means people failed a little bit, and people finished the game without failing at all. And you can see that when you compare these two groups, people who failed a little bit actually enjoyed the game more, which is good. But to be honest, I find the philosophical argument much more convincing. Press button to complete game. I hope we can all agree that this is not the most exciting game there is. And if you look at it from a different theory, which is a theory of fun, the theory of fun basically argues that fun is a response to learning. And if a person has solved the game, for example, if you objectively know how to play the best version of tic-tac-toe, it is not fun anymore because there's nothing to learn. There's no sense of failure. There's no sense of growth. So if you even take a different theory that underlines how fun and engagement is created, failure is rather important, and you can see that. So to improve game inclusivity, minimizing failures and making video games easy, really not the way to go forward. Failure is essential, and we need to be respectful of its inclusion in games. So what should we do? I claim that to improve game inclusivity, we should make games more accessible experiences and more effective teachers. Let's go look a little bit deeper into what I mean by accessible experiences. Disability is not just a health problem. It is a complex phenomenon reflecting the interactions between features of a person's body and the features of the society in which he or she lives. This is the definition of disability from World Health Organization. And a lot of my thinking about this topic is actually informed by this book, Mismatch: How Inclusion Shapes Design. And what Holmes says is disability arises through a mismatch between a person and the context that they're in. And in our case, the context is going to be referring to the games that we play. So what we're trying to do is actually reduce the mismatches and not necessarily make games easy or minimize failures. People are diverse. Big claim. When I was thinking about disability a few years ago, I was looking at it from this perspective. If you had a disability when it comes to touch, for example, you had one arm, or if you were blind, you couldn't see, you had a permanent disability. And that was the extent of my understanding. But there's more to it. You could be temporarily disabled. Last year, I broke my collarbone, and I was temporarily disabled when it comes to using my right arm. Or you could be situationally disabled. If you have a nephew, for example, you'll find that it is rather difficult to play games that require both of your hands holding a baby. And so one way games actually try to respond to this problem, let's say, or these mismatches, is through assist modes. So what are assist modes? Assist modes are options that the player can activate or choose not to do so that help them play the game. This game that you're looking at is called Mario Odyssey. And assist mode in Mario Odyssey will show arrows in the map, and it will help you go wherever you need to go. And if you fall down a platform, instead of going all the way to the back, you're actually going to be put right wherever you jumped. And as I said, when I had a broken collarbone last year and had difficulty playing the game, I actually used assist mode. But also a little bit more interesting to me, I used to play this game on a projector. And when I was playing it during the day, it was really difficult to see where I was going, especially in the level that you see on the screen, which has snow in the background. So turning on the accessibility mode helped me, even though I have pretty good eyesight with my glasses. And so making games more accessible helps everyone, regardless of your current mismatches. So that's what I mean when I talk about making games more accessible experiences. So how about making them more effective teachers? Simply put, if you cannot learn to play the game, you are excluded. And unfortunately, because a lot of the people who make games play a lot of games, they forget what it feels like to have never played a game. Most of you might be able to navigate in a three-dimensional space very easily using a mouse and keyboard. But if you put a 3D first-person game in front of someone who's never played games, you'll see that there's a big amount of struggle they'll have to go through. And a lot of games actually take that for granted. So teaching is a big source of exclusion. And so, well, what do games have to do? Games have to teach their players. Unfortunately, most video games suck at teaching. And what I mean by that is no one likes tutorials, onboarding, vomit. Great tutorials are hard to come by. We all hate in-game tutorials, the T word everyone skips, and so on and so forth. If you look at more aggregate data, you can see that games being hard to understand is a big obstacle in retention numbers. And it is important for us to really focus on the first levels because players decide whether the game is for them very early on in the first hour or so. And this game is for them aspect in some ways concerns itself with the genre, like, do I like this genre? But on the other hand, it concerns itself with the sense of belonging. Do they think they will be able to engage with the game? Do they feel comfortable pushing the boundaries and challenging themselves in that game? And there's a whole book that is written, a very underrated book that very few people seem to know, Learn to Play. It's a beautiful book, and one of the main claims that it makes is that good tutorials teach how to enjoy the game. So not only you're teaching people who don't know any game context, but rather you're teaching experts really how to get the most use out of the games. And so that's why I believe that we should also focus on making games more effective teachers. And my bigger claim is that we should use AI techniques to accomplish these two goals. Why should we use AI techniques? Well, first of all, AI techniques helps us respond to the diversity of players. And AI stands for artificial intelligence. One of the strengths of artificial intelligence is taking input, and then based on what the input is, coming up with what type of decision to make. And also, being able to play a game is very useful in assisting our players. And I'll make the case that there's been millions, maybe if not billions of dollars of investments put into AI techniques so that they play games very effectively. And we haven't really found a good way to utilize that in the games industry. So to be a little bit more precise, my first research question is, what lenses on games and the game design process will allow us to improve game inclusivity in games without negatively affecting the design intent? And this goes back to our discussion about failures and how important those are. 2, how might artificial intelligence techniques be used to intervene in game designs to design out the feeling of helplessness and exclusion effectively? And so during my last 4.5 years, I've contributed some theory and some code. Let's take a bird's eye view of the work that I've done. A diagnostic taxonomy of failure expands our vocabulary of failure in video games. SMES, adapting dexterity games, focuses on converting dexterity challenges into more deliberative challenges, planning challenges. Talon is a framework that will help you build more dynamic tutorials. Repurposing game playing AI surplus, we'll talk about how we can use the machinery that we put in a lot of investment in for inclusivity. And there's a research platform that helps us create reinforcement learning powered assistance methods. And so the first research question, what lenses on games and game design process, is answered by these theory papers. And the AI techniques for intervening in game designs are responded by these 4 projects. So without further ado, let's jump into a diagnostic taxonomy of failure in video games. I have to convince you at this point that failure is a necessary component of games. And there are certain genres of games that actually hold failure as a very, very integral part of their DNA. Dark Souls, Getting Over With It, Darkest Dungeon. These 3 games are basically marketed and pitched as like really difficult games. And Rogue, which is actually built in UC Syracuse in, I think, in the 80s, I'm not so sure, is a game that created a genre called roguelikes. And a big component of roguelikes is failure. You start the game, you play a little bit, you fail, you start again, but you know just a little bit better. So the loop of engaging with the game has failure as a big, big core component. And even if you look at games that do not necessarily pitch themselves as like, yeah, failure games, you'll see that failure is an important part of it. So let's say you're playing Mario. If you finish the whole game without even failing once, maybe you're not having that much of a good time because you're already mastered the game, right? So failure is an important concept of many games. I'm not going to claim all, but many games. And yet, not all failures are good. Sometimes you fail and you're like, let's go, let's try again. And sometimes you fail and your response is more like this. So what gives? If some failures are good, how do we tell which ones? And how do we tell? And in order to answer these questions, let's start at looking at like which ones are good and which ones are bad. And to answer that question, I introduced this concept of in-loop failures and out-of-loop failures. Let me explain this terminology using an example. Imagine you're playing Jenga. Jenga is a game where you have this huge tower of blocks, and you need to pull a piece, put it on top. Your opponent pulls a piece, puts them on top, and whoever drops the piece and the whole thing crumbles down is the loser. Okay? You drop the piece. That is a physical manipulation failure. And what I mean by that is you're physically manipulating a piece and you dropped it. You failed in your goal of putting the piece above. Is this a problem? No, it is not a problem. When I say a problem, is it a problem when it comes to the design of the game? The fact that this type of failure exists isn't a problem. Why? Because this failure, dropping the physical piece, is supported by the core gameplay. What I mean to say by that is the whole game is predicated on you moving pieces, and failure is expected. Someone is going to fail in their physical manipulation abilities at some point. Let's look at another game, chess. Let's say you're playing chess in a new chessboard that is curly and it kind of looks alien, and you drop the piece. It is, once again, the same type of failure, right? You are trying to move a piece, but because the chessboard isn't designed very well, you dropped it. Is this a problem? Well, yes, because chess has nothing to do with physical manipulation. Chess is much more about planning, counter plans, counter plans, and being able to think. Your ability to execute your plans, moving the pieces, should not be challenging at all. It should be very simple. And if you make a mistake there, something somewhere went wrong. Why? Because dropping the piece is not supported by the core gameplay. So the same type of failure, physical manipulation failure, you drop the piece and you drop the piece, can be an in-loop failure in one game and out-of-loop failure in the other game. In-loop failures are failures that are expected to happen in the game loop, and out-of-loop failures, they are not expected to happen in the game loop. Rather simple. So this is how we differentiate between in-loop and out-of-loop failures. But so how do we tell which failures are in-loop and which are out-of-loop? For that, we look into the taxonomy of failure itself. And this is a model, interaction model of how people play games. And this is building on Dan Norman's work and Stevenson's work. First, I claim that players have a mental model. And this mental model basically describes or contains what the player thinks about the game. And this contains the moment from marketing starts, like I hear the name, I start having an imagination of what the game is, to my current experience engaging with the game. Using this mental model, I make a plan. So let's say we're talking Mario. I know how Mario moves because I played some earlier platformers. I played Mario a little bit. So I make a plan. The plan is like, I'm going to jump on that Goomba and then jump on that platform. And I have to execute this plan. Am I able to actually jump on the Goomba and jump on the plan? Actually press the buttons. And depending on the results of these button presses, I'm going to update my mental model. It's like, no, Mario cannot make that jump. I thought so, but I couldn't. So I'm going to make a small update. And I divide the player mental model into two groups. One is called discovering mechanics, and the other one setting goals. Discovering mechanics describes the player's understanding of how the mechanics are actually working. And setting goals is, as you suggest, learning more about the goals of the game. And this is more for open-ended games. And the player actually engages in this loop every second continuously. But in order for them to be able to engage in this loop, there are two more requirements. First, they need to be able to encode their input to the system. What I mean by that is the player needs to know what the buttons are, and the player needs to be able to physically press the buttons. If a game requires two hands and you only have one, then you will not be able to encode your input as you wish. And also, the flip side of it, the player needs to be able to understand what's coming out of the game, decode the input. For example, if you have color blindness, or if you're blind and the game is projecting you pixels, then you will not be able to decode what's going on. These 6 classes constitute the diagnostic taxonomy of failure. So what do we do with this? We basically ask our game whether a specific category of failure is an in-loop or out-of-loop failure. So let's take physical manipulation. And that is an execution failure, right? Like you decide to move a piece and you're moving it and there's a failure. So in Jenga, execution class of failures are accepted. You're moving the piece, you drop, it's fine. But in chess, it is an out-of-loop failure. And what this allows the designers to do is basically look at your game, understand what challenges your game should put on the player, and then identify what challenges the game shouldn't put on the player. And whenever you see a player failing in an out-of-loop failure class, make a design change, have an intervention. And this actually helps analyze playtesting and so on and so forth. And so that was the diagnostic taxonomy of failure in video games. And using this taxonomy, I built my upcoming or the next projects, the following projects. So let's look at Talent, dynamic tutorials. Talent helps people in the discovering mechanics class of failure. I'm a really good, well, not really good, but pretty good strategy game player. I grew up playing strategy in 2003 when I was 8. My dad bought me Warcraft 3, so I know what I'm talking about. And so when I started playing Dawn of War 3, this game that you see on the screen, I was a little bit peeved because it told me to pan the camera to the stronghold, and it told me pan the camera to throw stronghold, and it showed me to press the arrow keys to pan the camera to stronghold. On the right, it showed me where the goal was. And on top left, it told me pan the camera strong. And then I really got it. After the 5th time, I got it. So I was so annoyed that I stopped playing the game. Instead, I decided to draw. I opened up my favorite tutorial on how to draw an owl. I started by drawing these circles. And then next step was drawing the rest of the owl. And this I did not get. So the problem is, in most video game tutorials, everyone gets the same help. And as you saw just now, that is not necessarily sufficient. Some people are overburdened by the tutorial and some people don't get help they need. So Talent is a dynamic tutorial framework that gives the player help when they need it and only when they need it. How does it work? It's pretty simple. First, the designer defines a skill that is used in the game. For that, we use Daniel Cook's skill atoms theory. What the skill atom is there's a player action, pressing a button. There's simulation that the system actually simulates, and then there's a feedback. So the player says, like, this happened. A concrete example is jumping. Jumping is a skill. The player presses the A button. The system interprets as a jump command. There's jumping code that executes, and then the player updates their understanding of it because there's an animation. I can jump. So after defining all the skills, all the primitive skills that you have in your game, then you update your belief on players' mastery of these skills. Does the player know how to jump or not? And to do that, you actually use detectors. Let's pick a different skill. Let's pick the skill of knowing when to break a wall. The wall that you see on the left is breakable. And if the player is within that green circle and not breaking the wall, they're just waiting and waiting and waiting, then our confidence in the player's ability to break the wall, whether they know it or not, slowly goes down. And when a threshold is passed, we trigger an in-game event. So if we're a little bit more confident that the player really doesn't know how to break the wall, then we do something about it. It is a Unity asset. And one thing to note here that this framework is based on game objects. So whenever you instrument a game object with this, all the copies of this object throughout your game gets instrumented. So this means that you distribute your tutorial all throughout your game, not in the first level. Let's see how this looks like. This is an example game without Talentified tutorials. You can jump, you can go left and right. And the skill that we're going to be talking about is dropping off the ledge. When you come here, immediately tutorial tells you what to do, so there's no sense of discovery. But in the Talentified version, you can actually set the components up and you can start the game, and we can talk about the technical specifications, but they're not very important. The ledge drop skill starts with a certain number. If the player is next to the ledge and they're not dropping, then our belief in their knowledge about the skill goes down. When it crosses a threshold, particle effects start. And then if they still don't get the hint, a prompt comes. And that is how Talon works. And it allows designers to instrument their game with more dynamic tools. Now let's look at a different project called SMES. And what SMES does is it takes in execution challenges and it converts them into planning challenges. So that's what the goal of SMES is, to convert dexterity challenges to planning challenges. And while we were designing, we realized that we were trying to make a tool to make games in the wild a little bit more accessible. So we started off by reaching out to potential users. So we ran an informal study on Reddit, going to several subreddits. One was disabled gamers, and the other one was tool-assisted speedrun, because the tooling that we're making is somewhat similar to how speedruns actually work out. And speedrunning is a concept where you play the game as fast as possible. But instead of explaining this project myself, I'm going to let my undergraduate collaborator, Hunter, explain the project.
Short video to show you the basics of how the SMES works. The SMES stands for Sharp Multi-Input Editing Software and is meant to help mitigate failure in dexterity-based games. However, we are also excited to see the full extent of its capabilities. Here is our current model of how the tool will operate. Here's the interface before gameplay. To get an idea of how the tool works, let's do a simple movement at first. We'll move to the right and then jump. Here is what the SMES looks like after recording those two inputs. Here, we see a player taking some actions in a platformer game. Oh, but whoops, looks like they messed up their jump. Here's the interface after it has recorded the gameplay session. To the left we see the buttons that are recorded, and in the center we see boxes representing when during the recording that button was pressed and for how long. Along the top we see a timeline showing when these buttons were pressed since the start of the recording. If we were to press play, we'd be able to replay that set of actions solely from this new recording that the SMES has created. As such, we will still fail that same jump. Let's make some changes. You can use the SMES to change when and what buttons are pressed. Here, let's hold right for a bit longer, press up twice instead of once, and jump a little bit less. Now that we've edited those buttons directly in the SMES, it can replay our new handcrafted recording. Looks like we're still a bit off that jump. That's okay though, we can do this same process again for as many times as we like. Let's go in and redo some things again. Now let's see if this will work. That's it! We were able to clear the jumps. And that's all there is to it.
So SMES was an interesting project because that allowed us to think about play traces, the sequence of game inputs, button inputs, in a different way and visualize them differently so that the player can engage with them. And I think there is a lot more work to be done in how you can support players' engagement in those traces. All right. And now let's go back to theory and talk about how we can repurpose game-playing AI agents. In 2016, I think, AlphaGo was released by DeepMind. And AlphaGo was an AI system that learned how to play Go really, really well. So well that it actually managed to beat the world's best player. Several years later, OpenAI released OpenAI 5, which was an AI system that learned how to play Dota really well and beat almost the world's best players in Dota. And a few years later, StarCraft released AlphaStar, which was a system that learned how to play StarCraft very well and beat really, really good StarCraft players. And I was a PhD student across all of these moments, and I was like, wow, we can destroy our players. We can beat them very well. Amazing. And yet, I was also growing as a game designer during this time. And I've really come to learn that obliterating our players isn't the goal in most commercial games. And when I say beat, obliterate our players, I know that we would probably be using different techniques like A-star, MCTS, Minimax, planners. If you don't know these techniques, don't worry about them. But my point is, even though all these three projects use reinforcement learning, this project that I'm talking about right now is agnostic to the underlying system. So let's assume that there is a competent game playing AI that you have access to, and let's assume it's a black box. Right? So if you have the system that knows how to play the game very well, and decades of research went into creating this system, and a lot of money went into this, what can we do with this box? And remember, we know how to beat our players very well, and yet obliterating our player isn't the goal. And so my answer to this question is use your game playing AI agents to assist your players. Let's go back to Celeste. Celeste is one of my favorite games, and it's really, really difficult. It's a platformer game. And Celeste assists its players very well using an assist mode. And I would like to read out how they describe their assist mode because I think it's very elegant. Assist mode allows you to modify the game's rules to reduce its difficulty. This includes options such as slowing the game speed, granting yourself invincibility or infinite stamina, and skipping chapters entirely. Celeste was designed to be a challenging but accessible game. We believe that its difficulty is essential to the experience. We recommend playing without assist mode your first time. We understand that every player is different. If Celeste is inaccessible due to its difficulty, we hope that assist mode will allow you to still enjoy it. And to be a little bit more precise, what it allows you to do is it allows you to change the game speed, give yourself infinite stamina, infinite air dashes, even make yourself invincible. And so when I say use your game playing AI agents to assist your players, this is what I mean. But if we already have Celeste assist mode, what can we use the AIs for? Well, we can do a little bit more intricate things. For example, if you have a strategy game, and strategy games require you to think macroeconomically, building the economies and building the factories and the workers, and also micro perspective, where you have to move the individual units. Maybe just say, hey, AI agent, handle the microing of the units. All I want to focus on the economic part. Or maybe you're playing a football game or a sports game, and you play the match, and then after the fact, the agent actually tells you where you can improve. Hey, you made that pass, but that actually reduced your ability to score. So next time, consider doing this, AI as a coach. Or you're playing Celeste, and the AI agent gives you the perfect way to move toward the part if you really want to practice your execution skills, and you just don't want to care about the planning aspect. So if this is the idea, but how do we systematically come up with assistance methods? Well, there's a design exercise with that. Challenge types, then you construct Zoom. Am I still? Can you all hear me?
Yes.
Okay, great. I received a message saying that Zoom crashed, but apparently it did not. 1 second. All right, Zoom. Is my screen still shared?
Yes.
Yep, you're good.
Oh. The first step of identifying the different challenge types. So let's say we're talking about Celeste.
Your screen's gone, Batu.
All right, great. Thanks, Zoom. Okay, it's not that bad. I think we're back on track. Can you see the screen?
Yeah, can you just start the slide over?
All right. All right, let's get back to it. So we're still talking about Celeste, and I say that I claim that there are two different types of challenges in Celeste. The first one is planning. It is deciding on which route to take, like how to go, where to jump, when to jump. And then there's the execution challenge. And of course, you can recognize these from the Taxonomy of Failure, but that is not necessarily, you don't have to use it. If you have different challenge types, you can pick whatever axis you want. So after deciding on the challenge types, what you do is you construct a design space. So on one axis, we have execution. On the other axis, we have planning. But what are these axes? They are the magnitude of game playing AI assistance. So the more to the right, the more the AI agent is helping you. And this space that is spanned by these two axes is the design space, AI assistant design space. On the top right, we have the traditional game playing AI agent fully playing the game because it is taking on all the challenges, maximum planning help and maximum execution help. So it's just playing the game. And on these parts, we have the only execution assistance or only planning assistance. And now the interesting part comes in. What if we pick a random point in this space and ask, what would that assistance look like? So on the top left, if our agent is helping us on the planning part, I call that assistance type ghost. We implemented this in a Unity clone of the game. And what happens is you press the assistance button, a ghost spawns and shows you which route to take. You know what the plan is, but you have to execute it yourself. On the flip side of it, when you're helping with the execution aspects, we implemented a click to move assistance method where you have to decide what route to take. So you convey that information by clicking, but it's up to the agent to take the route that you've suggested. And we can start scaling down the assistance impact to come up with different types of assistances. Well, what's more interesting to me is what happens if the AI agent is helping you on both of these axes. We can pick a random point in the space and ask the question, like, what would it look like if an assistance was helping almost all of planning and most of execution? And so this exercise actually allows you to come up with a platform, a portfolio of assistance methods for your game. And it's up to the designer to decide which ones are important to implement and which ones are not. And so we talked about theory about like, we should do this, we should do that. So in this project, I did that, and let's see how that went. And reinforcement learning powered assistance methods is a project where we're helping the player in the execution and planning aspects. So this is our final goal, what we want to create from the technical standpoint. We want to create a navigation agent that can start in a 3D map and then navigate to its goal effectively. The orange character is our agent, and the blue capsule is where the goal is. So we're talking about a point-to-point navigation assistance system. And you can see that it is jumping and doing relatively complex physics moments, and that's what we're trying to get. So what is this project? Well, the first step is to actually creating that agent. We use reinforcement learning to train a navigation agent. And this is the agent that I've trained. It is not a hypothetical goal, but this is the outcome. We first use RL to train a navigation agent, and then we use navigation agent to assist the player. It has two parts. So why are we creating a navigation agent? First, navigation is a key player skill in many, many games. If you can't navigate in many games, you can't even access the rest of the skills and exciting parts. And initially, I was thinking about creating a new game that was a different way to play it, and then the AI agent would help the player learn the new game I created. But then I realized, like, then my insights that I create will only be useful for that specific game. And I really wanted these assistance methods to be useful for other games. And because navigation is so foundational to many games, the assistance methods that we find can be transferred to other games as well. And in assistance, you can actually support the player both in execution and planning challenges, which makes the separation a little bit easier. And finally, it contains an easily measurable goal. Was the agent able to navigate to the goal, which makes the experimental part easier. How about reinforcement learning? What is reinforcement learning? Reinforcement learning is actually a problem statement, but I'm going to explain it with a little bit more hand waving. This is our agent. This is the character that is taking actions in our environment. And the world in which the agent lives in is the environment. So the agent takes in an observation from the environment at each time step. What that means is the agent gets some information, where it is, where the goal is, a little bit more information about its surroundings. And then as a response, like, the goal is that way. I know I'm here, so I'm going to come up with what action to take. And the action is just simply, well, I'll go this way then. And through this observation action loop, the agent gets a new information, decides what to do, does it, gets new information, decides what to do. But to what end? Well, the agent is actually trying to maximize the reward. Initially, the agent knows nothing. It does things trial by error, and randomly it gets some rewards. And then I was like, I got some reward. Let's try to maximize that. And in our case, the reward is related to reaching the goal. So why are we using reinforcement learning? Well, first, it handles complex 3D movement relatively well. We showed that in the short video and also our prior work when I was working at Ubisoft. And traditionally, navigation is done using navigation meshes. And it's a useful tool, very powerful. But one thing navigation meshes aren't really good at is ensuring that the agent can do everything the player can do. So what I mean by that is that when you use a navigation mesh, the agent can only navigate on the spaces that are blue. If the player somehow manages to jump on top of this bridge, then the nav mesh agent cannot get there. But in reinforcement learning, because the player and the agent is using the same action space, whatever the player can do, the reinforcement learning agent can do as well. And that gives us some useful attributes when you're supporting the player, because we really want to support the player everywhere the player is. And RL can surprise the developers, and this becomes rather important when you're testing a new game. And coming up with new insights is rather interesting from a testing perspective. And finally, reinforcement learning agents can describe how good the state is. And I believe this is going to be relevant when we're using our AI agents for coaching. So let's go a little bit deeper in the reinforcement learning aspect of it. So I talked about these three components. Let's look at them individually. Our observation constitutes of 4 parts. One is a vector, which has information about the goal position, the direction, velocity, and so on and so forth. Then we have a concept I call Occupant Secret. So the agent basically knows whether the empty space of these boxes is filled by a mesh, a physical object. The agent knows if there's a wall next to it or not, effectively. Then we have raycasts that tell the agent whether there's something in front of it. If it's blue, if the raycast isn't hitting anything, it's red if it hits the wall. And finally, there's another set of raycasts that are set up a little bit differently to support the agent's ability to identify where the ledges are ending. And that's what the observation is. And after the agent takes in this observation, it comes up with an action that is incredibly simple: movement on the x-axis, movement on the z-axis, and jump. And we discretize the jump because it's a binary input. And finally, our reward function. Our reward function, once again, is rather simple. The agent gets a high reward for reaching the goal. There's a shading reward for moving towards the goal. And then there's existential punishment, which means the agent takes a small bit of negative reward every step, and that allows it to pick up the pace and get to the goal as fast as possible. And we're using potential-based reward shaping. What potential-based reward shaping does is it ensures that the underlying Markov decision process is optimal when you add the shaping rewards. All that is to say, what we want the agent to do is reach the goal, not move towards the goal. So this theory allows us to ensure that moving towards the goal addition doesn't dilute the importance of the original goal. And it's a very simple implementation. What you do is you basically subtract the discounted shaped reward from the previous state when you're giving the first reward. If you're more interested, we can talk about it offline. And so on our engineering part, we have a Unity project, which creates a game binary, which talks to our stable baseline external library through ML Agent Python API, which outputs a neural network in the ONNX framework. We use Barracuda to run inference in the Unity project. And for our experiments, we use soft actor critic. It's an off-policy algorithm that is relatively good with sample efficiency, although we see that PPU is comparable. If you're interested in more technical details, we can talk about it after the presentation. And this is our target environment. So in 10 million steps, roughly 16 to 18 hours of training time, we can actually see our agent reaching almost 100% success rate in this environment. So our best performing model succeeds 993 out of 1,000 times. It's important to note that even though this graph looks very smooth and nice, it took a lot of work in deciding what the observations were, what the algorithmic changes were, so it is not a solved problem just yet. And one simple ablation that we ran was to compare the default hyperparameters. So you can see how much of a difference having the default hyperparameter versus tuned ones. And we also have 2 ablation studies about the layer sizes and also different observations in the paper. If you're interested, you can look at the dissertation. And so we say the best model, but we actually, in that 993% success rate, we actually sample our space randomly. So what that means is we can put the agent there, we can put the goal there, and we can say, go to the goal. And the agent can reach that goal very easily, and that will only tell us the agent has learned how to walk straight, which is nice, but not good enough. So we came up with a more representative testing suite. We placed 5 different goals that we found was interesting from a gameplay perspective. We recorded ourselves reaching those goals, and then we discretized all those different steps. And when we did that to all the goals available, what we got was around 1,000 agent goal pairs. So whenever the agent is in one of these points, we create a data set of this point with this goal, this point with this goal, this point with this goal. And in order to test our agents, we ran through this data set 3 times, and we got a success rate of 98.6. So we believe that this number is more representative of the player's experience when they're using the assistance. And more importantly, we actually looked at the differences between those failure modes. Because if you have an assistance system and it kills you by falling, by letting you fall down, that's a huge problem. Whereas timeouts, normally a big problem, is less important, mainly because the player can always intervene and take control. And so how about the assistance methods? This is the environment that we're going to look at for how the assistances look like. This is the game. You can move back and forth. You can press space to jump, and you have to get to the blue part to finish the level. This is our assistance space. Let's look at what the game looks like when the agent is fully playing the game. Maximum planning assistance and maximum execution assistance. On the bottom left, you can see that I'm pressing E and not pressing any other buttons, which activates the assistance. And the agent simply takes the player to the goal. There is no gameplay happening beyond that. What happens if we're only helping with the planning aspect? It is the same type of assistance that we talked about, a ghost. So here, the agent is helping with the route to take by becoming a ghost and showing the route which the player should take. And on the flip side of it, when the system is helping with execution, we have click to move. What it effectively does is wherever you're looking, you can press E. It will create a secondary goal, and the agent will directly move there. And you can start seeing some usability issues, but we're going to talk about them in just a moment. What I find a little bit more interesting, though, is this middle space. So this only jump assistance is what happens when the agent is handling the jumping. So you can see that the agent is jumping, but I'm not pressing space. I now only need to focus on movement, WASD, and the agent will jump knowing where I want to go. And similarly, we can just say like, hey, agent, you handle the movement, the player will jump. And suddenly our navigation game turns into a one-button playable game. Right now, the agent is trying to move us towards the goal, but we're stuck. Whenever we jump, the jump happens. This shows a really interesting usability challenge because the agent isn't aware of the player's existence. So this becomes a rather difficult way to play the game because the player has to learn what the agent is about to do and react to it. And so these different 5 methods represent our assistance methods that come from this single model. And if you want to play these yourself, you can actually go to the website and play them yourself. It is on my HIO page. You can find it by Google. All right, so the last part, navigation assistance research platform. While I was going through this project, I realized I was wearing many, many different hats. First, I needed to create a game environment. And then I took that game environment, became an AI researcher, and trained a model. I thought about like training curves and all that. Then I took that training model and I put on my game designer hat and I thought about like what assistance modes there be. And then after the assistance modes are created, I took that assistance mode and put on my HCI researcher hat and started thinking about, what are some evaluation advice that I should give? And I've realized all of these different bits and pieces are contributions in themselves. But if you're interested in doing research in AI-assisted inclusivity, you really need to have access to this whole research pipeline. If you don't have trained models, you cannot come up with AI-driven assistance models. So what this research pipeline is, it's effectively an open source project on GitHub that really tries to give components that serve each of these different perspectives. For AI researchers, you have gym environments and also baselines that they can compare with. For the game designers, we have the trained models in a simple interface where they can implement new methods. And for the HCI researcher, we have the built environment assistances where they can just play and test with their users. And of course, the whole Unity project is public that everyone can use. And so how am I currently using this research platform? Unfortunately, this information that I'm going to show is not included in the dissertation. From an HCI perspective, I can run user studies. So what you're seeing right now is a person having not a good time trying to play this game. And so then here's a video of them actually using the click to move assistance method. You press E and the agent goes to the goal. And here is them using the only jump assistance mode. So the agent is helping them jump and they're focusing on movement only. And so even in this preliminary work with the cherry-picked examples, you can see that it gave them a sense of participation, it helped them understand what to do, and it helped them learn gradually become better. We also used, so that was the HCI perspective. When I put on my game design perspective, we can actually use the system to help level design support. These are two levels that the students in level design class actually built. I gave them the original level, and then they used the system to iterate, get some insights, and then they built these levels. Here are some outcomes from this project, but I will have to move on due to time constraints, and then we can talk about it later. And finally, when I'm putting on my AI perspective, what I'm working on using this Navis platform is actually using the scene graph information to train the agents. So what does that mean? This is the level that we've been talking about, and there's the underlying data structure that represents this. So there's a bridge, there's a building, there's a floor, there's cubes in that, but we're not giving this information to the agent. So the GNN question is like, what if we do? Here is some fancy drawings about it. If you're interested in this project, please talk to me afterwards. Unfortunately, this is not included in the dissertation, so I'm going to skip. And all this is to help everyone else actually use this project and answer similar questions. And so we just talked about my body of work. I talked about the taxonomy of failure, SMES and Talent as two interventions, how we can use game-playing agents to support our players, and the previously discussed RL instantiation of this idea. And of course, I'm standing on the shoulders of giants, and also of my peers, and also everyday non-giant academics, and other game designers. Being a giant is overrated. And yet, I really, really hope that other people can build these, take these projects and build on top of them. Game inclusivity is very important, and we definitely need more hands on deck. And hopefully, with more research and everyone else that is working on this topic, we can slowly and surely ensure that people are not rejected from these social activities and the social connection that we build. And so hopefully going into the future, we'll be hearing less of these statements and more of these statements. This work has, even though I'm here presenting, this wouldn't have been possible without the myriad of people that supported me. So instead of going one by one, I'm just going to throw everyone who was with me throughout this journey in the last 5 years to thank you. Thank you all for being there with me throughout this process. And that has been Design Out Helplessness, AI Interventions for Inclusivity. I'm Batu Aytemiz, and thank you for your time and attention, and I'm open for your questions. All right. So now for the next next 7 minutes or so, we are open for questions from the audience. So you can either send them into the chat, unmute yourself and directly ask, or raise your hands. Okay, Max, go ahead.
Hey there, and sorry, let me turn on my mic for a sec. Yeah, okay, cool. Thanks for the talk, that was really great. I'm kind of curious about the relationship between your taxonomy of failures and the notion of failure as it's been understood in the context of like queer game studies and counterplay and stuff like that. And like, I'm trying to sort of wrap my head around what would be considered in loop versus out of loop in particular when players are like try to play to lose, for instance, or like trying to subvert the intent of the game. Yeah.
Yeah, I gracefully ignore that question by defining, ignoring the transgressive ways of play and stating that we are taking a normative approach when you're using this taxonomy and say whatever the game's implemented goals are, scores, what have you, is the way to use the taxonomy to make it easier. But effectively, that opens up a very interesting question, and that requires much more integrated conversations with the players. So I think there's a way to use it, but this is not the tool to really engage with it. But you can always extend it, talk to the players, and be like, wow, cool, people are using it this way, and let's be hands-off in helping them. I think that was the answer to the question, but to answer to the underlying question, a lot of my work in assistance, I am really trying to make things that the player keeps the agency. I really try not to predict on behalf of the player. So all of these different tools that use the taxonomy of failure and builds on, the player can engage with them or not, or they can take the assistance method and use them however they want. And that would be a great outcome. Anisha asks, is there a user study done with non-gamers using this tool? Yes and no. So we started preliminary user studies, and I asked I was working with undergraduate students, and I asked them to reach out to their parents or people who they thought didn't play games much. And the video you saw was from one of them. So they were non-gamers, but it was still a gaming context. If the question is this tool used in non-gaming context? Not yet.
What did you learn from the non-gamers, from the parents, after using the tool? Can you hear me?
Oh no, I was muted.
Yeah.
One thing that was counterintuitive was that people actually enjoyed the just press the button, have the game play itself system a fair bit. I was like, that sounds incredibly boring to me because I want to play the game. But the person you see on the screen, it basically said like, oh, it gave me a sense of participation. And honestly, that's all you need sometimes. For a parent to just be next to their kids and be able to have a sense of belonging, like, oh yeah, I can participate in this experience. That's all you need. And that was surprising to me, but also reassuring.
Thank you.
Sounds almost like the opposite of like those little kind of like roller coasters with kids where you steer and they drive.
Yeah.
I mean,
yes. Yeah. Yes. Matt asks, what did game design students discover when using Navis to design that level? So one thing that they discovered was, that I discovered was, it is very important when you introduce the tool. It was rather useless to give them the tool while they were doing exploratory analysis, but rather it was a little bit more useful when they were iterating on as something that was a little bit more fleshed out. And one unfortunate outcome was that people got affected by the tool. What I mean by that is they started making level design changes so that the tool could succeed, the agent could succeed. So in that case, the tool actually affected the design process. I don't see this being a bigger problem in more established studios. We were working with students with just a class project, but it was a surprising outcome that I wasn't expecting. Sugandha, fire away.
Yeah, this is not a game design question exactly, but I guess I was wondering, how much, I guess, research or literature or just what else you know about non-video game behavior or like just like random play behaviors. So, you know, like board games or games that children play when they're little on the street, so that sort of stuff. So like you're talking about the theory of fun and how it's a response to learning, and how that was the sort of responses you got from people who don't play video games is that it made them feel helpless. And I was wondering if any insight on how people think of fun or how they learn when they're doing non-video games, like games or not video games, and if that had any bearing on your
The question is, how does this work with non-video game stuff, such as board games? That is a long conversation that I'll have to come up with answers. So one thing that makes the AI aspect difficult is that there's no computational system that you have access to in board games. So the support needs to come from a different part. I have a lot of opinions about how to teach games to people, but I'll have to think how it directly connects to this work. Let's talk offline, but an interesting question nonetheless. Start by telling people what the goal is. That's #1 tip in teaching board games.
Nice, thanks.
So Chris asks, I'm interested in how this research could be applied to games with multiple solutions. Yeah, solutions like MOBAs, MMOs. Yeah, so that's a good point. You'll have to do a lot more work. Navigate. So I think one fundamental way to go about it is, how do you predict what the actual goal of the player is? And so how do you assist them? And that is a really, really, really interesting human AI interaction problem. I don't have the answers yet, but one way to go about it might be to basically create different components, like navigation component, and then bake them in and try to either ask the player like, yo, what is your goal? I'm very happy with asking the player instead of predicting, or using bigger data, but ask the player would be my general guess. my general approach that I would like to explore more. MJ asks, did you look at comparatively at the games that are designed asymmetrically, often for parents to play with? Oh, I'm thinking, no. So the question is, did I look at games that are specifically designed for people to play in certain groups? I did not, no. And it is a group of games that I'm not very excited in, because when I first started the SMES project, instead of making a tool that helped people engage with games in the wild, I thought about like, why not make a game that really targets this group of people? And that is not something that I'm interested in very much, because I want people to share the experiences of other people playing the games. So to answer your question, if a parent explicitly gets a game to play with their kids, I think that's a different situation than joining a game that the kid is already excited about. That being said, I should have looked into those, because I'm sure they have some good design insights to be found in them. And thank you. I will look into them. I didn't think about that. Yeet, go ahead.
Yeah, so I have a question about like more like game design perspective. So at the start of your speech, you mentioned like how some your distance with some aspects of the game, rather is being the community or like playing with your friends. Like I have a question, like how do we incorporate this teachings into the achievements side of the games? Because I found like most of the disabled players I've seen on the Twitter especially are talking about how playing at easy mode like restricts some achievements, or because achievements are built in a more stricted or more considered gameplay wise, so because they didn't consider about various kind of as you mentioned, this kind of teachings or assist mods. So how do we can use those techniques to making the achievements more inclusive and make the players are not distanced with this kind of community? Because as you might know, getting the platinum cup is important for most of the players, so I believe that could be a interesting part to consider.
Yeah, good question. So the question is, how do you merge the idea of achievements with assistance? My professional perspective on it is just like, I do not care if you use an accessibility mode to do the achievement. You can use all the tools you want and then reach that goal. It is a little bit more nuanced than this, because achievements represent prestige, and prestige is somewhat associated with scarcity. So it is not as simple as like, everyone gets every achievement and you can use all the tools to achieve. So I think you'll have to take that game by game. But my default answer would be I do not care if you used the tools to get your goal. But it's a little bit more nuanced than that, and we should talk on a case-by-case basis. All right.
Thanks.
I think we have one last question. Cyril, it's nice to see you, man.
Thank you. You too. Really cool to see how your research has culminated since we last spoke. So I'm thinking about how AlphaGo in particular, something that's really interesting about how that technology has been used over the last few years is that since the whole beating of the Grandmaster that happened in 2014, a lot of professional players have actually started using matches between two AlphaGo agents to try and learn the game more deeply, to learn what AlphaGo is thinking about in terms of how AlphaGo is approaching the game, and using that to improve the game from the human players. So what that has me thinking about is actually wondering, what are your thoughts on so using the sort of autoplay agent as a mode, and I guess sort of in some way kind of combining that with what you've done with Colin, and using that autoplay as a mode of teaching players, and sort of using that to just set them to gain their own skills in playing?
The answer to that question is yes. Big yes. I think that's a very good next step, and I'm really excited about that. I'll tell a story about it. Gary Kasparov lost to Deep Blue in 1998, and he's a world master chess player. And then after that, his response was like, chess is done. Instead of trying to play chess, let's play this game called Centaur Chess. So in the following tournament he started, what he did was he wanted people to join in by themselves plus an AI agent. So you don't compete with AIs, you don't compete with people, but you compete with a centaur that is human plus AI agent. And then what was the most interesting is the winners of that tournament, of that centaur tournament, was not the strongest AI agent, nor the strongest player, but rather the team that had a good system to extract the most information from the AI agent. So there's a lot of interesting ways to think about, like, well, we have this really competent system, like how do we actually utilize the capability that is in that? And I think that's a huge, research area that I'm very excited. But to answer your question, yes. Okay. All right. Last question. If you're given the power to make any video game, just one in the world, accessible to every single person interested in playing it, which game would it be and why? So the answer to that is, I don't think games should be accessible to everyone. I think not every person will be able to play every single game. And I think it is impossible to make a single game accessible to everyone. I don't think that will work with how much importance I put in its design intent. That being said, so we need to be trying to include as many people as we can, but everyone I think is a pipe dream. But to answer your question that you're actually asking, yeah, it would be good if people got to play Beyond Good and Evil. It's a nice game. All right, and with that, I think we should end the public Q&A aspect. So thank you all once again for coming. I'm really excited to see all of you all. And now I'm going to ask you to leave.
Bye, Batu. Good luck.
Bye, Batu. Yay! Congratulations.
Congrats.
Thank you. Thank you.
Bye, Batu. Well done.
Yay,
Thank you, Tad.
Great job, Batu.
Amazing.
Take care, Batu. It was great.
Nice seeing you all.
Congrats.
It was a nice piece. Thank you.
Harikaydı.
Very well done.
Görüşürüz.
Sağlık abi.
Afiyet olsun.
Yes. Once again, Batu, I'm glad this is not a contest. Good luck with the private part.
Okay, I will slowly kicking people out.